Hello, today we're going to be working with points, lines, and planes note. So our vocabulary is a point is a location that has neither shape nor size. So here the example of a point is A. A line is made up of points that have no thickness or width. There's exactly one line through any 2 points. So here our line is letter M, and it's represented by the points P and Q. A plane is a flat surface made up of points that extends indefinitely in all directions, meaning it keeps going and going. There is exactly one plane through any 3 points of through 3 points not on the same line. So we have D, B, C. Those are our points, and our plane is plane K. So using this information, we want to, in this figure, find a line containing point Q. So we want to look at point Q. So point Q is right here. So we want to find a line with point Q. Well, we could have Q, R. That can be our line. We could have Q, T. We can reverse these and say RQ and TQ. But those are the same things. It's like saying first name, last name, and over here it's saying last name and first name. We also have, looking at this, we want to come up with a plane containing point S and point T. So through these 2 points, we want to come up with a plane. So our plane is Q, S, and T. So we used S and T, and then we also threw Q in there as well. So name the geometric terms modeled by the objects in the picture. So if we look at this, we have a notebook. The geometric term the notebook is a plane. And the letters are J, K, and L. The same thing, looking at the notebook, we have the notebook edges. When we have the notebook edges, you notice they make a line. So the notebook edges make a line. So these are lines. Examples of these would be JK, line JK, and line KL. What else here? Well, we also have a quarter. The quarter is going to be a point. It's going to be point M. What else? We also have this pin, and that's going to be a line as well. P, Q, or we could say line P, R. Looking at this, using another idea, collinear, points that lay on the same line, that would be P, Q, and R. That's why we had for the pin 2 different points, because they are collinear. Next up, let's take a look at example 3. So in example 3, we want to draw what we have. So we're going to draw and label a figure to represent the relationship. So we have line QR and ST intersect at U. So line Q, here's the points for line Q and R. Then we have point S and T. So let's start plotting this out. So Q is going to be over here at -3, -2. So here would be Q. And then R is going to be over here at 4, 1. This would be R. It's not going to be perfect, but here's the line that goes through them. And then we have S is going to be at 2, 3. 1, 2, 3. This would be S. T is going to be at -1, -5. 1, 2, 3, 4, 5. This would be T. Again, I'm going to try to make it as straight as I can. Now in my notes, I have this down that this right here, this point right here, this is point U. And point U is the intersection. Of the two lines. Then we want to come up with a point P that is coplanar, meaning that it's on this coordinate grid, but it's not collinear. It's not on either of these lines. And it can be anything that's not on either of these lines. I'm just going to make a point that's kind of over here because we have nothing over here. So I'm going to say the point -2, or +3, 1, 2, 3. So this would be point V. So point V. And again, you can put it anywhere you want. I just put it over there because of the fact that we had nothing there. And I knew it wouldn't be on line QR, and I knew it wouldn't be on line TS. Now let's take a look at this drawing that we have here. So looking at this drawing, we want to come up with how many planes are in this figure. Well, if we look at it, this figure has 1, 2, 3, 4, 5, 6 planes. It has plane P. It has plane CAG. It has plane GFA. It has plane EFA. It also has plane DEA and plane DCA. You can pause it to check for each of these planes, but these are all the planes. Now we want to name 4 points that are collinear, meaning that they're all going to be on the same line. And if we have this line right here, we would have H, I, C, and F. So those would be points H, I, C, and F. Now we want to name what the intersection of plane GAC. So we have GAC, so that's this back plane right here. Where does that intersect plane P at? And it intersects plane P at this point right here, GC. You see this point? This is where the plane meets this figure. So plane GAC intersects plane P at GC, line GC. And then what do points JI and DC intersect? So we want to find where JI, so that's JI right here, and DC. Well, JI is going up and down, DC is going left and right. They don't intersect. Do not intersect. Okay. Now we want to look at these ideas in the real world. So we got a biplane that has 2 main wings that are stacked one above the other. What we're going to do is we're going to identify each part of the plane and determine what it is. So each wing, well, that's going to be a plane. If you think about it, they are flat surfaces that extend back. So that is what a plane is, a flat surface. The struts, those intersect between the two, and they intersect at a point. So they intersect of struts and wing is a point. And then we have our flying wire, and our flying wire crosses the two flying wires cross at a point. The two fly wire. So they cross like right here. I'll highlight it for you, right here, right here. Then our struts point here, point here, point here, and point there. So we learned about a lot of different things today. Go ahead and review through the notes. Write a summary of what we learned for today.